There are common Subaru mods that are quietly destroying engines, not obscure modifications, not extreme builds pushing 600 horsepower on a stock block. The exact modifications that thousands of everyday Subaru owners install, thinking they're improving their car. I'm talking about mods sold on every performance parts website, mods that have thousands of 5-star reviews, mods that look completely harmless, sound great on a test drive, and seem to make the car better in every way you can perceive from the driver's seat. And underneath all of that, several of these mods are accelerating wear on your engine, stressing components that were never designed for the additional load, and setting you up for failures at 80,000 to 120,000 miles instead of 250,000 plus. The frustrating part is that most of these mods don't cause immediate obvious damage. There's no check engine light the day after installation, no dramatic failure in the first month. The damage accumulates slowly and invisibly, exactly like the cold start wear and fuel quality issues we've covered before. By the time symptoms appear, you've already done thousands of dollars in damage, and most owners never connect the failure back to the modification that caused it. Today, I'm going through the most common Subaru modifications that are genuinely problematic, explaining exactly why each one causes damage, and telling you which mods are actually safe if you want performance gains without sacrificing engine longevity. Whether you have a WRX, a modified Outback, or you're just considering your first upgrade, you need to see this before you spend another dollar on parts. Let's get into it. Mod number 1. Aggressive aftermarket tunes without supporting mods. Here's the most common engine killer in the entire Subaru modification world: an aggressive ECU tune installed on an otherwise stock vehicle. What people do: buy a flash tune from a tuning company promising 30 to 50 extra horsepower, install it in 20 minutes using a handheld device, drive away feeling the immediate power increase. Why it destroys engines. A tune increases boost pressure, advances ignition timing, and adjusts fuel delivery to extract more power from the same hardware. But the hardware wasn't upgraded. The stock fuel pump, stock injectors, stock intercooler, and stock turbo are all still there. Aggressive tunes frequently push timing closer to the knock threshold than the factory calibration allows. On a hot day with slightly lower octane fuel, or after some carbon buildup raises the engine's natural knock tendency, that tune can trigger real, sustained knock events instead of the rare correction the factory tune was designed to prevent. Stock fuel pumps and injectors are sized for stock power levels. Push them to their absolute maximum flow capacity with no margin, and you risk a leaner than intended air-fuel mixture underboost, which is one of the fastest ways to melt a piston. The real-world damage ringland failure on cylinder 4 of WRX engines, the most commonly reported catastrophic tune-related failure, frequently traces back to aggressive timing maps combined with marginal fuel quality. Cost of this failure: $5,000 to $8,000 for a full rebuild or engine replacement. The fix: if you want a tune, use a conservative, reputable tune designed specifically for stock hardware. Ideally, one developed by a tuner with extensive experience on your specific platform. Run premium fuel exclusively, and understand that even a safe tune still uses more of your engine's available margin than stock calibration, so combine it with more frequent oil changes and closer monitoring of engine health. Mod number 2. Aftermarket intakes without proper filtration. Here's a mod that seems completely harmless and is actually causing widespread engine wear. Aftermarket cold air intakes, particularly open element designs. What people do: replace the factory airbox with an open cone filter intake, chasing the deeper intake sound and the marketing claims of increased airflow and horsepower. Why it destroys engines. The factory airbox isn't just there to look stock. It's specifically engineered to draw air from a cool, low-turbulence location while shielding the filter element from splashing water and road debris. Many popular open-element intakes relocate the filter into the engine bay, directly in the path of hot air radiating off the engine and exhaust components. Hot air is less dense, which actually reduces power in real-world conditions despite dyno charts showing gains in a controlled cool air test environment. Worse, open-element filters in the engine bay are far more exposed to water during heavy rain or deep puddles. Hydro-locking, where water gets pulled into the cylinder and causes catastrophic mechanical damage because liquid doesn't compress like air, is a well-documented failure mode specifically associated with these intake designs. Beyond water, these filters are also more exposed to road dust and debris in certain designs, leading to accelerated filter loading. And if the filter media is lower quality, microscopic particles passing through into the engine and causing accelerated cylinder wall wear over tens of thousands of miles. The real-world damage hydrolock repair, $3,000 to $8,000 depending on severity, frequently a total engine replacement if water reaches multiple cylinders. Accelerated wear from poor filtration, difficult to quantify precisely, but oil analysis on vehicles with cheap open-element intakes consistently shows elevated silicon levels, indicating dirt and dust contamination getting past the filter. The fix. If you want an intake upgrade, choose a closed-box design that maintains a sealed connection to cool outside air, away from engine heat and away from water exposure during deep puddles or heavy rain. Several reputable manufacturers make Subaru-specific closed intakes that deliver genuine gains without the water exposure and heat soak problems of open-element designs. Before we continue, modifications that increase engine stress make all of the foundational maintenance practices we've covered even more critical, not less. I've documented exactly how to adjust your maintenance schedule for modified Subarus in the 500,000 mile car maintenance blueprint, link in the description. Mod number 3, aftermarket downpipes without proper tuning. Here's a mod that's popular on turbocharged Subarus and frequently installed incorrectly: aftermarket downpipes, especially catless or resonated designs. What people do: install a downpipe to reduce back pressure and increase exhaust flow, often without getting the car professionally retuned afterward. Why it destroys engines. Removing the factory catalytic converter or resonator section changes back pressure characteristics and exhaust gas temperature readings at the turbine. Your factory ECU calibration was built around factory back pressure assumptions. Without a corresponding tune, the ECU may be working with inaccurate data from oxygen sensors that are now positioned differently relative to the exhaust flow, potentially causing the ECU to run a leaner mixture than intended under certain conditions. Beyond the tuning mismatch, catless downpipes also dramatically increase exhaust gas temperatures, reaching components further down the line, and in some cases the turbine itself runs hotter due to reduced back pressure changing flow dynamics. The real-world damage lean condition damage from oxygen sensor confusion, piston and ring damage similar to detonation damage, in the $4,000 to $7,000 range for repair. Premature catalytic converter failure on the secondary cats further downstream, now working harder to compensate, $800 to $1,500 per replacement. The fix: never install a downpipe modification without a corresponding professional tune from someone experienced with your specific exhaust setup. If emissions compliance matters in your area, choose a high-flow catted downpipe rather than a fully catless design. You get the majority of the performance benefit while keeping the ECU's emissions-related sensor data closer to expected ranges. Mod number 4. Lowering springs with mismatched shocks. This one doesn't directly destroy the engine, but it destroys other expensive components fast enough that it deserves inclusion here. What people do: install aftermarket lowering springs for appearance and handling while keeping the factory shocks and struts. Why it causes damage. Factory shocks are engineered with a specific valving and travel range matched to the factory spring rate and ride height. Lowering springs change the spring rate and compress the available shock travel. The shock is now operating outside its designed range, frequently bottoming out over bumps because there's less available travel before the shock reaches its internal limit. Repeated bottoming out damages the internal shock components and accelerates wear on strut mounts, control arm bushings, and even wheel bearings from the increased impact loads transferred through the suspension. The real-world damage premature strut and shock failure, typically within 20,000 to 40,000 miles instead of the expected 60,000 to 80,000 plus miles. Accelerated wheel bearing wear from impact loading, bearings failing at 50,000 to 70,000 miles instead of 100,000 plus. The fix: if you lower your Subaru, install a matched coilover system, or at minimum pair lowering springs with shocks specifically valved for the reduced ride height. Several reputable suspension manufacturers sell complete matched kits specifically for this reason. Mod number 5. Boost controllers. Set too aggressively. For turbocharged Subaru owners specifically, manual or electronic boost controllers are extremely common and extremely commonly misused. What people do: install a boost controller and turn the boost up well beyond factory specification, chasing maximum power numbers without considering what the rest of the engine can handle. Why it destroys engines. Boost pressure directly increases cylinder pressure during combustion. Higher cylinder pressure increases mechanical stress on connecting rods, rod bearings, piston ring lands, and head gaskets. The factory boost level was calibrated with margin built in across the entire mechanical system, not just the turbo itself. Pushing boost significantly higher without addressing supporting hardware like upgraded rods, reinforced ring lands, or stronger head studs means you're relying entirely on factory components to absorb dramatically increased stress. The real-world damage, ringland failure and rod knock under elevated boost, are among the most commonly documented catastrophic failures in the Subaru turbo community, frequently occurring well before 100,000 miles on engines pushed beyond safe boost levels without supporting modifications. The fix: if you want more boost, research exactly what your specific engine's factory internals can safely handle before adjusting anything. Many Subaru turbo platforms have well-documented safe boost ceilings on stock internals, typically modest increases over factory, not the dramatic increases boost controller marketing often implies are safe. Mod number 6. Polyurethane bushings. Throughout the drivetrain. This is a more subtle one that surprises people, because the mod is marketed entirely around improved handling and responsiveness. What people do: replace factory rubber bushings throughout the suspension and drivetrain with stiffer polyurethane bushings for sharper handling feel. Why it causes damage: factory rubber bushings aren't just there for comfort, they absorb vibration and shock loads throughout the drivetrain, protecting transmission mounts, differential mounts, and subframe connections from the full force of every bump and torque pulse. Polyurethane bushings transmit significantly more of that vibration and shock directly into the connected components instead of absorbing it. Over tens of thousands of miles, this contributes to accelerated wear on transmission mounts, increased stress on CVT, or manual transmission internals from harsher torque transfer, and even accelerated wear on motor mounts not replaced with the bushing upgrade. The real-world damage. Most damage here is gradual and difficult to attribute directly, but mechanics who work on heavily bushed Subarus consistently report earlier mount failures, and in CVT-equipped models specifically, theorize the harsher torque transfer characteristics may contribute to accelerated belt and pulley wear, though this connection is less definitively documented than the other mods on this list. The fix: if improved handling feel matters to you, consider a more moderate approach. Upgrade only the bushings most directly affecting handling response, like sway bar end links and front control arm bushings, while leaving drivetrain-adjacent bushings in factory rubber to preserve their shock-absorbing function. The mods that are actually safe. Not every modification is problematic. Here's what genuinely improves your Subaru without meaningfully increasing engine wear risk. A properly engineered closed-box cold air intake with reliable filtration and cool air sourcing. Conservative, professionally developed tunes specifically calibrated for stock hardware, paired exclusively with premium fuel. High-flow catted downpipes installed alongside a proper supporting tune. Matched coil-over suspension systems, where springs and shocks are engineered together. Upgraded brake pads and rotors, since braking performance doesn't carry the same hidden engine stress risks as the modifications above. Cosmetic modifications, wheels, body kits, lighting upgrades, and interior changes carry essentially zero mechanical risk when installed correctly. The underlying pattern. Looking across all of these problematic mods, a clear pattern emerges. Every one of them works by removing a layer of engineering margin that Subaru built in deliberately, without replacing that margin with anything else. The factory tune has margin for knock. The factory airbox has margin for water and heat protection. The factory downpipe has margin for accurate sensor readings. The factory shocks have margin matched to factory spring rates. The factory boost level has margin for the mechanical limits of stock internals. The factory bushings have margin for absorbing shock loads. Every genuinely safe modification either preserves that margin or replaces it with an engineered equivalent. Every dangerous modification removes the margin and replaces it with nothing. Before installing any modification, ask yourself specifically what engineering margin you're removing and whether you're replacing it with something equivalent or simply hoping the stock components can absorb the difference. The bottom line. These common Subaru mods are destroying engines, not through dramatic failure, but through the slow removal of engineering margin that was protecting your engine all along. Aggressive tunes without supporting fuel system upgrades push timing and fueling closer to dangerous limits. Open element cold air intakes expose your engine to heat soak, water, and contamination. Catless downpipes without proper tuning create lean conditions that damage pistons and rings. Mismatched lowering springs and shocks destroy suspension components rapidly. Excessive boost without supporting internals leads directly to ringland failure and rod knock. Aggressive polyurethane bushing upgrades transmit damaging vibration into drivetrain components. If you want performance modifications, choose the ones engineered as complete systems rather than isolated parts bolted onto a stock platform expecting it to absorb the difference. And if you've already installed any of these problematic mods, don't panic, but do adjust your maintenance schedule accordingly. More frequent oil changes, closer monitoring for knock or unusual noises, and honest awareness that you've reduced your margin for error compared to a stock vehicle. And if you want the complete maintenance system adjusted specifically for modified Subarus, including how to compensate for the additional stress these popular modifications create, check out the 500,000-mile car maintenance blueprint in the description. If you found this video helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.